Okay, guys, let's just continue with that problem that we did yesterday. I think some of us were a bit confused with that uh, problem. So I just want to work it out and see if we can solve it together, right? So this was the question. Find the steady state errors for the following inputs: 5 into u of t, 5 into t u of t, and 5 into t square u of t to the system shown in this figure, right? So here we see that the g of s is equal to 120 into s plus 2 divided by s plus 3 into s plus 4, right? Now what we do here is that we look at the inputs. So the first input that we have is 5 into u of t. So u of t, we know that it's a step input. The Laplace transform there is 1 by s. So this will be 5 into 1 by s. So it will be 5 divided by s. Then the next one is 5 into t u of t. We know that t into u of t is a ramp input. So it will be 5 into 1 by s squared, where 1 by s squared is the Laplace transform for a ramp input. And the next one is 5 into t squared u of t, which is a parabolic input. So we know that for parabolic input, t into u square of t, so when you take the Laplace, it actually becomes 2 into 5 divided by s raised to 2 plus 1. So it will be 10 divided by s cube, which is the Laplace transform. Okay. Now we go back and we look at the formulas for each of this. So let's take the general formula to start our work with. If the other formula confuses you, we can start with the general formula and then we can apply it onto the system. So here is the general formula. Now when we start for the first question, we know that it will be 5 by s, right? So that is the step input. So we're going to say e of infinity step is equal to limit s tending to 0 s into 5 by s, right, divided by 1 plus g of s. So s and s will cancel. You have limit s tending to 0, 5 divided by 1 plus g of s. Right. Now we substitute limit s tending to 0, 5 divided by 1 plus this term here, that is 120 into s plus 2 divided by s plus 3 into s plus 4. So if you take that and you put it here, right, okay, let's just do this. Let's bring all of this onto the side here, and let's see if we can put this here. Yeah. So now if you have a look, all the terms with the s, they disappear. So the s here, that goes away, this one goes away, and this one goes away. So it becomes 5 divided by 1 plus, if you do the maths here, you will see that it's 120 multiplied by 2 divided by 12, which is 20. So you get it as 5 by 21. That is the error due to the step input. Now if you go and have a look at the next one, that is the error due to the ramp input, e of infinity ramp. And if you take the same equation, that is e of infinity, let's take the same equation, and let's see if we can solve it here. This becomes limit s tending to 0 s into, if you have a look here, what was it was 5 divided by s squared. So 1s and 1s here will cancel out, divided by 1 plus g of s. So essentially this becomes 5 divided by s plus s into g of s, because the s at the numerator comes to the bottom. Of course there will be limit s tending to 0, and automatically this s becomes 0 when you apply limits. So this can be written as 5 divided by limit s tending to 0 s into g of s. Now when you apply the same formula, if you go and have a look here, you will see that s into g of s, you don't even need to do the calculation here, because s is 0. So 0 multiplied by g of s is equal to 0. So this will be 5 divided by 0, which is equal to infinity. Now if you do the same for the parabolic input, you will see that the only difference here is that this becomes limit s tending to 0 10 divided by s squared into g of s. Again, s is 0, so it will be 0 multiplied by 0, so it will be 10 divided by 0, which is also equal to infinity. So this is how you do the problem. So have a look and let me know if you have any doubts on this one. Thank you.